What up? I want to give you an example of how we work in this equation when we do functions and relations within the functions. Okay, so let's say we've got old Billy. And Billy works down at Larry's Pizza. And at Larry's Pizza, they pay good money. He gets to see girls, and he's like, hey, girl, I'm making money. And she's like, oh, that's cool. Take me on a date. He's like some Larry's Pizza? Sure do. Come on down. I work there. Cool. All right? And he likes Larry's Pizza because he makes $10 an hour. Okay? Now, you've got two things here. You've got your X and your Y. One's input is the X, Y is the output. Okay? Now, the two things we're working with in this problem, the two things that are hanging out together in Billy's life with the money he makes at Larry's Pizza. He makes $10 an hour. That's set. Dude makes 10. He ain't getting no raise. He's just a worker. He's not a great worker. Okay? He's got his hours that he works, and he's got the money that he makes. Which one of those depends on the other one? A lot of times to figure out which one's the independent, which one's the dependent, it depends a lot on looking at the dependent first. Do we think the amount of hours he works depends on the money he makes? Or do we think the amount of money he makes depends on the hours he works? Deuce could do. We can too. The amount of money he makes depends on how much he works. Okay, they're not going to pay him more money. They're like, oh, here's $400. You must have only worked this many hours. Okay, no. X is going to be your hours worked because that's what he controls. He controls how much he works. The money is based entirely off of how many hours he works, okay? This depends on this, all right? So you've got 10, that's $10 an hour. We're going to multiply that by how many hours he works, and that's going to tell us the amount of money old Billy's making and how many dates he's going on. I'll give you a hint. It's a lot. That's a pretty good money, okay? So, if we want to make a graph about this, let's say I did it in chunks of 5. 5, 10, 15, 20, 25. Okay? So this is how many hours he works. Along the x-axis, that's where your x goes. Okay? That is your input. That's where it goes, is on the bottom. All right? And then the y depends upon whatever this is. All right? So for instance, we've got y is money made. Let's do $50, $100, 150, 200, and then 250. Okay? Convenient numbers, I know. Okay, so if we put in 5, that's our input. So we're putting that x into that problem. So we go 10 times 5. 10 times 5 is 50. So our ordered pair is 5 for the x, 50 for the y. So 5, 50, we make a point. Okay? Same thing for 10. Put 10 in there. 10 times 10 is 100. So 10 and 100. Input, output, x, y, every other name I can think of, 10, 100. And as you can guess, it keeps going up as we put those in. And then we get a line. And we can look on this line. And anytime we go over, like, what if he works 40 hours? You get here, you go up to wherever they meet, and that's how much money he makes. Okay? Domain, what is the domain? It's anything x can be. X can be anywhere from 0 hours to 100 hours. Can it be negatives? No, they're not going to negative hours. They don't take away $10 for every hour you don't work. It's not that kind of job. It's Larry's Pizza. Calm down. All right? And then his range can be anywhere from $0 to whatever. Okay? So his domain, x is greater than or equal to 0. Y is greater than or equal to 0. So it's a pretty easy domain and range. Just remember your domain is connected to your x. Your range is connected to your y. All right? And that pretty much sums up graphs and functions. I hope you enjoyed yourself.
Hello. Thank you for coming to Tarver Academy. Please subscribe, maybe